At Doosan, we're always viewing the world in unique ways. For example, did you know the Earth processes air much like a compressor? The weight of our atmosphere actually compresses air, generating 14.7 pounds of pressure per square inch at sea level. An air compressor processes that same air we breathe to store energy and adapt it for use in countless applications. Let's look inside a typical unit. Ambient air enters a compressor through a filtered intake which removes dust and dirt. This filter should be replaced at timely intervals to ensure the compressor is protected from unwanted contaminants. Dirty or restricted filters cause pressure drops and reduced efficiency. Filtered air continues through sealed piping to an inlet valve that controls the volume of air reaching the air end and prevents oil from reversing towards filters after shutdown. Next, air enters the air end, which is a fixed displacement pump that uses two helical rotors to compress air. As the rotor screws turn, they form a partial vacuum which sucks air into the helical rotors. The amount of air that fills the air end is measured in cubic feet or meters per minute. As air travels along the helical rotor flutes, the space stored in the air gets progressively smaller. Since the air cavity between the rotors is larger at the inlet end and smaller at the discharge end, air becomes compressed, creating significant heat. During the process, oil is injected into the rotors and serves three critical purposes. 1. To lubricate the rotors, bearings, and seals. 2. Seal the space between rotors to keep pressurized air from escaping back to the inlet. And 3. Remove heat from the system so the air end can run at optimal temperatures. Using oil to maintain proper temperatures maximizes efficiency of the compression cycle. The air, now mixed with oil, exits the air end through a discharge port and is piped to a separator tank. Here, the separator will remove some of the oil from the air and let it accumulate in the pressurized tank. The tank acts as a reservoir as well as an oil service and fill point for maintenance. A sight gauge mounted on the tank's side allows an operator to quickly check the oil level. Next, hot oil flows from the bottom of the separator tank and through the oil temperature bypass valve. If the oil is too hot, it moves through a cooler to lower the temperature. The oil temperature bypass valve also acts as a mixing valve, taking hot oil from the separator tank and cooled oil from the cooler and mixing them into a perfect temperature for the air end. The oil is then filtered and returned to the air end, ready to do its job all over again. Back at the separator tank, the air is almost ready for use. Air exits the pressurized tank and passes through an element filter which reclaims most of the remaining oil from the airstream. The air is then piped out of the compressor to the service air valves where it can be used for thousands of applications.